Hello all and welcome back to this decision analysis course video lectures, and now we are in chapter 4 section 2, the function D matrix for decision matrices. So what I will do here, I will explain how to use my code D matrix to solve decision problems. There is also the code listing here, so you can see how this function is implemented. I will not go through the implementation. So if you are experienced coder, you can, or you should look through the code and see how it works. But if you are not very experienced in programming and you have problems understanding how the code works, so how it's implemented, don't worry, you don't have to know how it's implemented, you only know how to use it. So the M file dmatrix.m that you can download from these notes. You should download it to your GNU Octave working directory. It defines a function, so I call it, so here is the syntax, d result equals d matrix parenthesis d problem. So d problem is the argument, so that's a struct type variable that defines the decision problem, and d result will be a struct type output value that gives you the solution. And in the AMP files, I'm usually write d problem solved as dp and dr solved as for d result. So I can use, of course, any names here that I wish. The d matrix, of course, has to be like it is. And let's look at the input parameters. So d problem, what is the d problem? It's a structure type variable that defines the decision matrix problem and has the following fields. So it has a field d rule. That's a string that determines the decision rules to be used. And what are the supported decision rules? There's opt for optimist, pes for pessimist, hur, note the capital H, so the capital and small letters are not the same in Octave. So that's the Hurwitz rule. Then regret rules, that's the regret aversion. Lap, again note the capital L, Laplace rule, EV expected value, and Kara, well, this maybe should have been capitalized, but they are not capitalized, so there's small Kara, so that's the constant absolute risk aversion. So this field is mandatory. It's obvious in the decision analysis, you have to decide what is the decision rule. So you have to give the field decision D rule to this decision problem D problem. What else you have to give to define the decision problem? You have to have the decision matrix or reward matrix. So this is called DMAT, this field. So this is a matrix whose rows are the alternatives, the columns are the scenarios, and this is a mandatory rule. Then there is a rule that is not mandatory, so it's O degree. So this rule is the, O degree. This is the degree of optimism in the Hurwitz rule. So this was denoted by W there. Here it's denoted by O degree. So it's a value between 0 and 1. And this field is only needed if the decision rule is Hurwitz rule. So Hur here. Otherwise, you don't have to give the O degree. You can give it, but it will then do nothing. Then there is a prob. This is a column vector. Note it has to be a column vector, otherwise things won't work. And these are the probabilities of the scenario. So this is the vector P, and this field is only needed for the stochastic decision rules. And what are the stochastic decision rules? In this list, there are the EV for expected value and Kara for constant absolute risk aversion. So this is required only for these two rules. And finally, there is RTOL, so this is the risk tolerance, and this is only needed for the Kara rule. Otherwise, you don't have to give this. So once all these are given and you call the function with the D problem with these fields given, then the function returns a D matrix. The function D matrix returns a struct type variable, whatever you call it. Let's call it D result here, and it has always the following two fields. So there's a D values. So this is the value function V. So this is a vector giving the values of the decisions. So this is what I have denoted by capital V in this lecture notes. And then there's D optim. So this is the index of the optimal decision. So this is the I star that was in these notes I have denoted by I star. So I star is D optim. Then depending on how you call what is your decision problems, there can be other output values. So if the decision rules regret, then the D result has the field RMAT that contains the regret matrix. Just there for fun. You don't need it, but if you want to look at it, you can look it there. And also if the decision rule is SCARA, then the D result has a field UMAT that contains the utility matrix. So the UIJ is the U of RJ. Again, this is not needed, strictly needed anywhere, but it's there just for fun. And a small point, why do I use structure type variables? So some people don't like them. They are very convenient here because unlike in many other programming languages, I don't have to fill the fields if I don't use them. So it's very dynamic. So the reason to use structure type variables is that in GNU Octave one does not have to define fields that are unnecessary. And also if one defines fields that are not used, they don't cause any problems. So it's very convenient and easy to use. So here is the listing of the function dmatrix, function file dmatrix.m that defines this function dmatrix. As I said, I will not go into the details on here. So if you are fluent in programming or you have some experience, then you can look through it. It's not too complicated, but if you have anxiety about programming, for example, then there is no need to go through this code. Only thing that you need is here this is the link. You click here, it downloads this code, and you should put this code into your working directory for Octave. And finally, a word of warning, this function dmatrix has no input checkings whatsoever, meaning that it works with the mixing bullshit in, bullshit out. So if the input variable d problem is not properly defined, then the output variable d result may be nonsense. Caveat emptor. So really, it's up to you to use this correctly. The function does not detect improper input. That was all for this section. See you in next video lectures. Bye.